Morning geometry classes. Let's take a look at lesson 11.2 samples to practice and get ready for our quiz 11.2, where we're finding areas of sectors, an area of circles, and other information about circles such as diameters and radii. All right, so sample 1 asks you to figure out the area formed by angle DFE. So I've actually colored in the sector that is the area formed by angle DFE. So that's what we're trying to figure out. How many yards squared is this area, given the information that the radius of the circle is 2 yards and that the measurement of this sector from D to E here is 120 degrees. Well, we're going to go back to the proportion where we can relate two ratios part to whole to set up an equation that will allow us to solve for x, which will be the area of the sector of the circle. So what we're going to do first is we're going to establish x is going to stand for the area of the sector, the yellow part. And so that part of the circle, that sector, compares to the entire area of the circle. This is pi r squared. R is 2, the radius is 2, and we're going to square that radius to place it in the formula pi r squared. And that's going to be equal to the degree measurement of the sector, 120 degrees, to the measurement of the entire circle all the way around. So that would be 360 degrees. So x over pi times 2 squared is equal to 120 over 360. Then we'll use cross products, and we'll be able to write 360x equals 120 times pi times 2 squared. Then we can divide both sides by 360, and we'll have x is equal to 120 pi times 4 divided by 360. You can plug all of this information right here into your calculator if you want, or you can simplify, which I chose to do. I like to use smaller numbers, whether I'm working on my paper or in my calculator, wherever possible. So I notice I can divide both 120 and 360 by 120. So 120 divided by 120 is 1, 360 divided by 120 is 3. And so I'm going to rewrite this information as x is equal to 4 pi over 3. And at that point, I will throw all that in my calculator. 4 times pi divided by 3. And remember, we are using the value of 3.14 for pi, which is an approximation. And that is going to give us the result that you see here. If you are using the pi button on a graphing calculator, it will be more accurate, and your answers will differ slightly from what you see here. So when we throw all this in our calculator, we will see on our display 4.186666. At some point at the end of your display, there will be a 7 because it'll round this off. And then you're going to round to 2 places past the decimal point. That is our protocol, unless we are told otherwise. And so that rounds off to 4.19 yards squared. So this sector here, the yellow area of the circle, has an area of 4.19 yards squared. Sample 2. So sample 2 asks you actually to go in the other direction. This time you're going to be given the area of the sector, and from that you are to figure out the area of the entire circle, the sector piece and all of the part that is just white. So the entire area of the circle. Again, we're going to go back to our part to whole proportion setup, where we are writing two ratios that are equal to each other, part to whole. Well, we are told that the sector area, that part of the circle, is 12.36, and we are trying to figure out the area of the circle. That's our whole. You can use any variable you want. I chose to actually just write out that information that we're looking for, area of circle, and that's going to be equal to the degree measurement of the sector, the arc measurement here, or the central angle, 89 degrees, compared to 360. That would be the number of degrees in the entire circle. All right, so we're going to use cross products to work this out. Area of circle times 89 equals 12.36 times 360. And then we're going to divide both sides by 89. So the area of the circle will be 12.36 times 360 divided by 89. I don't see any easy simplifying there, so I'm going to put all of that into my calculator. 12.36 times 360 divided by 89. And on my calculator, I'll see 49.9955, And I'm going to round that off to the nearest hundredth. That will give me 50.00 meters squared. So that means the area of this circle then would be about 50 meters squared. All right, sample 3. So on this one, we're asked to figure out a diameter of a circle given the area of the circle. And so this time our dimension is going to be not a squared unit, it's going to be just a length measurement. So it'll be just meters in this case. So to figure out the diameter, first we're going to figure out the radius of the circle. Once we know the radius of the circle, we will go ahead and double that to get the diameter. We'll start with A equals pi r squared, the formula for the area of a circle. And I'm going to replace A with what I'm told the area is, 314.16 meters squared. And I've put all of this in a thinking bubble because this, what is written in red, was not given to you. All that was given to you were these directions, but I wanted to see a picture of what we were thinking about, so I drew the circle, I drew in the diameter, I wrote in the area that we're given, just to help me know how I'm going to plug into my formula. So my area is 314.16, and that's equal to pi r squared. Again, I'm solving for r. So at this point, I will go ahead and divide both sides by pi and reverse the sides. And then I'm going to take the square root of both sides. So to figure out my radius, I have to plug into my calculator the square root of 314.16 divided by pi. You can do all this in one step in a more advanced calculator, or even in a more advanced calculator, you can take 314.16 divided by 3.14 and then take that answer and take the square root of it. And that's going to give you that the radius is 10.0025 and some other digits past that. That will round off to 10.00 to the nearest hundredth. And then the radius has to be doubled in order to answer the question, what is the diameter? So I've noted that here, twice the radius is the diameter. So I'm working out twice the radius, twice 10, and twice 10 is 20, so my diameter then would be 20.00 meters. And remember, in this case, I am not going to put the squared here next to my meter because this is not an area measurement, it's a length measurement. All right, that completes all of our work now together for this samples for 11.2, so it's time for you to move on into your quiz portion of this lesson, and we will see you next time.